हेलो कोडर्स, वेलकम बैक टू माय यूट्यूब चैनल। इस वीडियो में हम बात कर रहे होंगे डॉकर के बारे में। विल अंडरस्टैंड व्हाट प्रॉब्लम डॉकर सॉल्व्स, व्हाई इट केम इनटू एग्जिस्टेंस एंड हाउ वर्ल्ड लुक्स बिफोर डॉकर केम इनटू पिक्चर। Right, we'll see how we can install Docker in our local machine, what are images and containers, what is port mapping, what is Docker file, what is caching layer. Then we'll create one application and we will publish it to Docker Hub. So Docker Hub is basically a registry similar to GitHub where we publish our code. So here we'll be publishing our application images, right? Then we'll understand what is Docker networking, volume mounting, multi-stage builds. We'll discuss brief about AWS ECS and ECR. So this video is for the person who is in software development field or who is aspiring to become a software developer, or for the students who want to make a project and they can explore this technology. So without wasting much time, let's dive in. So first we'll understand how world looks before Docker came into picture. So at the very initial phase, there were many companies, right? There were many companies and they were making application, they were building application, they are launching applications, and if they want to host the application, they have to either buy their own server or they can borrow it from the provider, right? So this is the server and they host their application. So this is the application. So suppose 200 people are using this application, right? 200 people are using this application, and after some time 3000 people started using this application. So of course the load on this server increases. So what they have to do, they have to buy another server, right? And they have to run this application on this server. So at that time only one application can run on this server, right? If they want to launch any other application or upgrade this application, they have to buy another server, right? Or borrow it from the provider. So this was the case at that time. So for every application, for every single application, they have to buy a server. So with time, the concept of virtual machine came into picture, right? Virtual machine. So what happens in virtual machine? So this is the host machine, right? So within this host machine, we can create a virtually isolated environments, right? So these are your virtual machines within a single host machine. So this virtual machine will have its own operating system, it will have its own dedicated storage, resources, everything. And inside this you can now run your application, right? Again, if you want to run another application, similarly you have to create a virtual machine, you have to set up all these operating system configurations, assign a dedicated storage, resources, everything. So though this was far better than the before, where you have to buy a dedicated server for running your applications, though it is not perfect, right? Because if you need to host any application, run any application, then you have to go and create operating virtual machines and then set up all these configurations for operating system, storage, and everything. So think how tedious this task were at that time, right? So so after this the concept of containerization came into picture, right? Containerization came into picture. So what happens, so this is your single host machine, right? This is a single host machine, and inside this you can create various containers, so we'll discuss what are containers, images, everything, right? No need to worry, it's just a brief of how the world has evolved, right? So this is basically a container and it will run your application, it will run your application. So we don't need to now install operating system, manually configure the settings for the operating system, storage, resources, everything. We don't need to do anything, right? We can simply run this container in which our application will be running in a single host machine. So see how this containerization concept made it so easy. Okay, now let's discuss one more scenario. Suppose if you're working on any application, right? This is a full stack application, and you have Angular 11 installed in your machine, you have Node version 10 installed in your machine, you have MongoDB 5, you have .NET 6, you have Redis 3. Okay, and so these are the dependencies of your application. So you write some code base, you install all this dependency, and you made this application up and running. So now this application is running well in your machine. Okay, now what you did, you invited other developer, and you asked, so suppose this developer is Ravi, so you asked, hey Ravi, could you please take my code base and try to run this in your local machine and give me feedback of how my application looks. So he says, okay, uh, please share your code base. So what he did, so he take this code base, and in order to run this application he need to install all these dependencies libraries that is needed to run this application. So he installed Angular, he installed Node.js, he installed MongoDB, .NET, Redis, everything, right? And he installed the latest version. But his application doesn't run. Why? Because of the mismatch, right? Because of the version mismatch. So what he will do, he will then again come back and will ask, hey, could you please tell me the version that I need to have to make this application up and running. So he said, okay, you should install Angular version 11, Node 10. Then what he will do, he will downgrade all this version to match the version in his machine, right? So he'll install version 11, then downgrade to 10, then Mongo 5, everything. Now this application is running, but you see how replicating the environment is so difficult, right? Replicating the environment is so difficult. Or suppose, or suppose this application is made for Windows, right? This application is made for Windows. He is having Mac OS, right? But now he can never run this application in his machine, right? So the main thing is here replicating the environment. Environment is basically all those dependencies, operating system, packages, modules, code base, everything that is needed to run the application. So, so this is so difficult. So Docker made it so easy, right? So Docker gives you a concept of containerization that we have discussed earlier also, containerization, right? So it gives you a container. It gives you container. So what this container will do, so what you can do, you can take the image, you can click the image of this state, right? You can click the image of this complete environment, you can take the image of this code base, you can take the image of this dependencies with their versions, right? Everything that is needed to run this application. So as it is, you take the image of this complete environment. So in this you have your code base, you have Angular version 11 installed, Node version 10 installed, MongoDB 5 installed, and everything, right? So you click the picture and you put it in a box. So this box is basically a container, right? Now if you want anyone to run in his local machine, or do you want to give it to any developer, what you will do, you can simply share this container, right? You can share this image and he can run in his local machine, right? And this Docker, it container, this will make sure that the application runs. Why? Because everything that is needed to run this application is inside this image, right, inside this image. So everything is already there. So if you run this image in his local machine, that it will make sure that it runs. Suppose even if in his local machine Node version 13 is installed, Angular version 13 is installed, it doesn't care. Why? Because this image will have Angular version 11, Node version 10. So the version that is needed to run this application is already there, right? It doesn't care about the outer environment or the dependency or the version that is installed in his local machine. It is a complete separate entity, separate environment. And now he can run this image inside his container. Okay. So now in his local machine he can run various containers, right? He can run various container, and inside each container will have his own data, right? It will have its own data. It will have its own data, but this data will not be available to the outside world. This data will not be available to this container. This data will not be available to this container. This data will not be replicated to this local machine unless and until you want, right? So this is a separate entity. So this is basically a container, right? And the application or the dependencies, everything that is whose image has been taken is image, right? Whose photograph has been taken is an image. So this image will contain everything that is needed to run this application, and this container will make sure that it is running inside a isolated environment. So we'll understand in deep what is container, what is images. So this is basically a brief. So if I ask you what problem does Docker solve, so problem Docker solve, so it solves the problem of replicating the environment, right? Replicating the environment. Okay. How it solves the problem? So it provides you a concept of container. So inside container you can place all your code base, all your dependencies, libraries, operating system, everything. And what you can do, and anybody who wants to run this application, so he can just pull this image and run in his local machine. He can run in this local machine, or even if you want to host it on the cloud, so on the cloud also you can pull this image and you can run it. You don't have to worry about manually installing all this dependency, matching the versions, nothing. Why? Because this image contains everything, right, needed to run the application. So you can simply pull and it will run in your server, right? It will run. You don't need to worry anything. Okay. So now what we will do, so now we have seen the problem statement, right? We have discussed the problem statement. We have discussed about the problem statement. Now we'll install this in our local machine. So you can type in Google download Docker, right? Download Docker. So the first link that appears is from the official Docker, right? So you can go to Docker desktop and you can install based on your operating system, right? Based on your operating system you can install Docker. Now I have already installed this in my local machine. So once it is installed in your local machine, and if you open terminal and if you type Docker, so you can see a lot of stuff appears, right? So if the same thing happens in your machine, then you can say that Docker is successfully installed in your local machine, right? If I type, let me show you the version that is installed in my machine. So if I type Docker version, right, so you can see that I have 27.0.3 version installed in my local machine. Okay, right. So as of now we have discussed the problem statement. We have seen how we can install. So once you install Docker, so if you go to Google, you have installed Docker desktop, right? Docker desktop. So this Docker desktop will have two things, right? Once you install Docker desktop, it will have two things. One is Docker daemon, Docker daemon, and second is GUI, right? So this Docker daemon is the actual Docker tool, right, that manages, builds your containers. And this GUI is basically a way to visualize the containers, images, everything. Okay, so if you launch Docker in a local machine, it will look something like this. So this is basically the GUI where you can see your running containers, your images, everything, and you have your Docker daemon, right? Docker daemon is actual engine basically which runs. Okay, so we have seen about the installation. Now we'll see what is images and what is containers, right? We'll see what is image and what is container. What is container? Right. So image is basically, it is the template or the photograph of your complete application, right? So this photograph or this template will contain your code base, your complete dependencies. This dependency includes the operating system, packages, right, modules, everything that is needed to run this application. Okay, so this image is basically the template of your application. Okay, what is this container? This container is nothing but a isolated box. Isolated box, right? So this isolated box, it is used to run this image. So this image is template, and when this is running, so the running instance is container. So what does it mean? So this is your local machine, right? This is your local machine, and if you want to run this image, right, so what you can do, so there will be one container, and inside this container this image will be running. This image will be running. So the only purpose of container is to run this image. Okay, and this container will make sure that it is a isolated entity, it is a isolated environment, it does not have a impact or does not impact with the outside environment, right? Either your local machine contains another version or anything. Okay, even if you create anything, install anything in this container, it will not reflect in your local machine or any other container on this local machine. So this is a separate entity. So container is basically a separate entity which runs the images. That's it. So now what we will do, we'll just run any run any images on your local machine, right? We'll run any images public that is public, and we'll try to run this image in our local machine. Okay, so now we have a registry. We have a registry called Docker Hub, right? We have a registry called Docker Hub. So this Docker Hub is same as GitHub. So GitHub, what we used to do, GitHub we used to publish our code publicly, right? So in Docker Hub we used to push our images. Okay, so let's go to Docker Hub. So you can type Docker Hub. So you can type Docker Hub, Docker, Docker Hub, right? And the first website is the official Docker Hub, hub.docker.com, and you can see a lot of images are present, right? So these are basically the images. These are basically the images. See, Nginx, Alpine, Mongo, Grafana, everything. So these are basically the images, right? You can search Ubuntu also, right? Ubuntu. See, Ubuntu. So in your Windows machine also, you can run this Ubuntu image, right? So now you will ask me, uh, if I'm running this Windows, if I'm running, so this is my Windows local machine, and if I run Ubuntu image, right? So how it is different from virtual machine? In virtual machine also, we in our host machine we used to run other operating system. We want to run Ubuntu in our Windows machine, right? So Docker, it basically, Docker on Windows specifically, right? On Windows, it uses a lightweight virtual machine, right? It uses a lightweight virtual machine. Okay, and it is managed by WSL2. So WSL2 is basically Windows subsystem for Linux too. Okay, and what does this do? So it will, this Ubuntu, it will share. So this WSL2, it provides you a kernel, right? Common kernel. So this Ubuntu will use the same kernel. This Ubuntu will have the same kernel, right? But what happens in traditional virtual machine? So suppose this is your Windows machine, and in virtual machine, this is virtual machines, right? You are creating a Ubuntu virtual machine. So this Ubuntu virtual machine will have its own kernel. This other operating system Linux will have its own kernel. So right, so every virtual machine, it will run a full instance of Ubuntu Linux, including its own kernel, as a separate entity on Windows host machine. So it is more resource intensive, right? But this WSL2, this WSL2, it is more faster and efficient. Why? Because it is optimized for Docker containers, right? It is optimized for Docker containers. Okay, so in this way it is different, right? So all this container, it basically shares the same kernel of your host machine, but in virtual machine, every virtual machines will have its own kernel, which makes it more resource intensive, right? Okay. So now we'll try to run Ubuntu in our local machine, right? So we'll go to our terminal. So we'll go to our terminal and we can write, docker run -it Ubuntu. So first, it will give a error unable to find images because this is not present in your local machine. So now it will start downloading Ubuntu from the Docker hub, right? So see, download new images from Ubuntu. So now, if now see, you are inside this machine, right? You are inside this Ubuntu. So now if you go to your Docker desktop, this GUI, so you'll see you have one running container, and the ID of this container will start for is this one, right? And this is exactly the same here. Okay, so if you do ls, see, you are inside this Ubuntu machine. Okay, so in this way you can pull any image and you can run in your local machine, so you don't have to worry about anything, right? Any dependencies, any module packages, you don't need to do anything. You can pull and run in your local container. That's it. Okay, let's come out of it. See, now you will see this container is stopped, right? Exited. Okay, if you want to see all the containers present, you can type docker, you can write docker container ls. So you don't have any running container, right? Docker container ls will show you all the running containers. If you want to see all the containers that are present, either it is stopped or running, you can type docker container ls -a. So you can see you have one container with the name Ubuntu that is exited about a minute ago, right? So you can see all the running containers, and also you can see all the containers that are present. So as of now we have covered right? So we have seen how we can install Docker, we have seen images and containers, right? Now we'll see what is port mapping. What is port mapping? With the help of application, we'll understand what is port mapping, what is Docker file, what is caching layer, and what is multi-stage build, right? So let's go to a very basic application. So this is .NET Core 6 Web API, right? Let's run this application. Okay. So this Web API, it exposes a endpoint. So it exposes a endpoint, and when you hit this endpoint, it gives you this static response, right? So this is very basic web application. Now what we want to create image of this application, right? We want to create image of this application. So you can have your own application, right? It can be a static website built using HTML, CSS. So you can also try to create the images of that application. Okay. So the first step that is needed to create image of this application is you have to create a Docker file. So you have to create a Docker file. So you have to keep the naming same as mentioned here, and it doesn't contain any extension, right? Now what is this Docker file? What is this Docker file? So we'll understand. So what I said, so if you want to create image of any application, so image of any application, so what you have to do, so the first step is to create a Docker file. First step is to create a Docker file. So what is this Docker file? So this Docker file, it contains all the instructions. It contains all the instructions that is needed to build and run your application. Build and run your application. Okay, understood. So, so in my case, I am having .NET application, right? I am having my .NET application. So what steps do I need to follow to build and run this application? I will mention that in my Docker file. Okay, I'll mention that in my Docker file. Docker file. So my first step would be to build and publish this application. Build and publish. And the second step would be to run this application, right? So there are two steps involved for .NET application, right? So to build application, I need ASP.NET image, right? I need ASP.NET image because it contains all the SDKs to compile and build this application. Then after, to run the application, I need .NET runtime image. .NET runtime image. Okay, so let's go to my Docker file. So this is my Docker file. Okay. So if you will see, so this image, this is basically image, right? So this image, it contains all the SDKs, all the tools that is needed to build my application. So what I did, so what I did, see, my application, it contains right, project file. Then it contains all the dependencies. Then it contains some source code, right? Source code. So first step would be to copy all this thing in my container, right? To contain all this thing in my container so that I can just build an image in this container. I can run this container. Okay. So what I'll do first, I'll first copy this CS proj file. So first I'll set the working directory. So this is my container. So I have to set a working directory. So I'll say within src. So within src folder, so this is my src folder. So within src folder, what I'll do, I'll copy first the cs proj file. So I'll copy my cs proj file here, project file, right? Then what I'll do, I'll run a command .net restore, .net restore. So uh, this will basically download all this dependency, install all this dependency that is needed in the application. Then what I'll do, then I'll just copy all this source code. I'll copy all this source code, right? Then what I'll do, I'll just run .net publish command. So .net publish command, what it will do, so .net publish command, .net publish command. So using .net publish command, it will create, so this publish command, it will create a folder, self-contained folder, and it will contain all the compiled application, right? All the DLL files, right? It will contain all the dependencies, all the dependencies, which can be NuGet packages, right? NuGet packages. It will contain the static files, right? It will contain all the configurations file. It will contain all the configurations file. So basically, it will contain all the things that are needed to run the application, right? So inside this folder, so inside this folder, it will contain all the things, right? Now, my second step would be to get everything from this folder and then run this application, run this application, right? So all these steps that is needed to build and run this application, I'll mention that in my cs project, my docker file. So if you go to my docker file, you will see, so I'm using this Microsoft .NET image to build my application. So it will contain all the SDKs, every tool to build this application. So what I have done, so I have just set my working directory of container. So this is my working directory for my container, right? Now what I'm doing, I'm just copying my project file to this location inside this folder. Then I'm running .NET restore command. So it will basically download all the dependencies needed in this application, right? Then this command, it will basically copy all the source code that is inside this folder, and it will copy to my containers working directory. Okay. Now first step is getting all the dependencies and copying the source code from here to my containers folder working directory, right? My second step would be to run this publish command. So this .NET publish command, it will create all the DLL files, all the dependency, and it will output this to this folder inside my container, right? Now my third step is to use this base. What is this base? This base is basically my runtime image, right? So this .NET ASP.ASP.NET is basically the runtime image. So I'll use this runtime image to get all the things. So what I'm doing, I'm from this publish stage, I'm copying all the things that is inside this folder to my this working directory inside my app folder, right? And then what I'm doing, I'm exposing 80. This is port number, so I'm exposing my port 80. So I'll basically, it will handle the request at port 80. And this is the entry point of my .NET application, right? DLL file inside this folder. So this publish folder also, it optimizes my application. How? It will remove all the unused code or dependencies, and it will make the basically output size smaller, right? So it will optimize my output file. So see, Docker file is nothing but an instruction, right? You can have instruction of how to build, how to run this image, so everything. Okay. So now what we understood, so we have understood what is this Docker file. So we have understood what is this Docker file, right? It is basically a instruction of how to build and run the application, how to create images of your application. Okay. Now we'll see, we have seen what is stages. Okay, so see, so this is basically one stage, right? This is one step. This is second stage. Okay, now why we are segregating the stages? Because see, while building the application, right, while building the application, we need all the SDKs, all the tools that is needed to compile and build this application, right? But while running the application, we don't need all those tools and SDKs, right? We only need the published folder DLLs, right? The output of this build command, publish command. We only need this DLLs, which is used to run the application. We don't need the whole things, right? Whole tool to compile and build the application again. So we are basically at this stage, we are dropping the other things which is not needed and only using the things which is required. And it will make the final image size smaller and it will be more optimized, right? So this is multi-stage build. That is why I use multi-stage build to optimize the performance, right? To optimize the final image. So we have understood what is multi-stage build. We have seen what is Docker file. Now we will see what is this caching layer. What is this caching layer, right? Okay. Now let's understand what is caching layer. Okay. See, every stage, right? Every instruction, every line in this Docker file is a layer, right? So if you don't change at any layer, so it will be cacheable, right? It will not build this layer again. It will basically use the cache version of this layer. So for example, if you do not change anything in this project file, if you do not add any dependencies or anything, so it will not rerun this command again, right? It will basically use the cacheable output, right? It will use the cacheable version. It will not run this command again. Okay. So suppose what you did, so you basically change the code, your source code, right? So at this stage, it will detect some change and then it will build this again. So it will build all the lines beyond, it will run all the lines after this line, right? It will build all this after all the layers after this layer, right? So whenever it detect any changes at any particular layer, it will build everything after this layer. Okay. But see, it is very important to order this layer. If you will not order this properly, it will lead to a more of more of a time taking image or not optimized image, right? For example, suppose also this is basically copying the source code, right? Suppose if I place it above this line, so if I place it somewhere here, right? Now see, if you change any small line in your source code, then what it will do, it will detect the change here and then again it will run the .NET restore command. But it is not required, right? Because we are not changing any dependency, we are not doing anything. So even for a small change in source code, it is running and restoring the dependencies again and again, which is a very time taking process, right? So that is why ordering layers matters, right? So you need to place it here so that if you're not changing anything in the dependencies, it will run once, and if you are changing any source code again and again, then it will start building from this layer, right? It will not, this layer will be cacheable. It will use this layers from the cache. It will not build it again. So that is why the order of the layers matter, right? So we have to take this into consideration while writing this Docker file. Okay, so we have understood what is this caching layer. Now we will understand what is this port mapping, right? What is this port mapping? So let's do one things. Okay, so we have written this Docker file. Now we can build this build the image, right? We can build image. So what you will do, so now what we'll do, we'll build the image of this Docker file, right? So now what we will do, we will just build the image. So using the command docker build hyphen t, so it is for tag, so you can give name to your image. So I'll give web API dot. So now what it will do, it will build your image, right? So if you go to your Docker desktop, so in the GUI you can see you have one image with name web API that you have currently given. Okay, so now it is on my Docker desktop. You can see that in your GUI, right? You can visualize this. Okay, so now what you want to do, you want to run this image, right? You want to run this image. So when you run this image, a container will be spinned up, and that image, this image will be run inside that container, right? So let's open terminal. Now what, so you can run your image using command docker run. What is this IT, I'll tell you, and the name of your application, so web API. Okay, so what it will say, you see the application is running at port 80. Okay, so if you go and run this in your browser at port 80, okay, so it is saying that can't connect to the server. Why? See, because this is, why? Because this is running inside your container, right? And container is a isolated entity, right? Anything that is inside the container, you can't access it from the outside until you want. So by default it is completely isolated, right? So what I can do to access this this endpoint, right? So how we can access from our local machine the application that is running on this port 80? So here comes the concept of port mapping, right? So you can map your local machine port to the containers port, right? So let's see how we can do it. Let's close this container. Now what I can do, see, I can write hyphen p, so this is for port mapping. Now what you want your machine 80 to map it with the containers 80, right? Because our application is running on port 80 on container. So you can map your 80 local machine port 80 to your containers port, right? Now what is this IT? So this IT is basically interactive. That means it is attaching your local machine terminal to the container, right? So now again if you press enter, okay, now the application is running on port 80 on our container, but we have done a port mapping, right? That means now we will be able to access this with our local machine. So now it is pointing to port 80. If you do reload, you will be able to see this, right? See, right? Let's again close this container. So if you close this container and if you reload this page again, see, you can't be able to access the server, right? So this is port mapping. That means you can map the port of your containers application to your local machines port, right? Okay, so now we have covered this port mapping, right? Now what things are left? Now what we will do, we'll publish this image that we have currently created recently to the Docker Hub, right? To the Docker Hub. Then we will see what is this Docker networking, Docker mounting, AWS ECS and ECR. Okay.